Okay, this is the tutorial for the Fizz domino. So we are going to be using Fusion as our CAM software, and this will be in preparation for getting you trained on the tormach CNC mill that we have. So just gonna make sure we got everything ready here. So I'm gonna load up this domino right here. This is what the end result will look something like. We'll eventually get to a point where we have a domino that is fully engraved. It's got all these nice add-ons to it. Yeah, so this is kind of what we'll be aiming for at the end. And to get started, I'm just gonna suppress these setups. Where is it? Suppress. This is just going to allow me to keep these here, but much of it will be the same as starting from anew. Okay, so we are machining this domino, right? Mine has this nice little engrave on the back, but generally the dimensions of your domino should match the ones in the previous tutorial I made for Engineering 101. There were some drawings associated with that you could reference. But it's going to be this, I believe, 0.3 inch thick domino. This should be about an inch long, I think 0.92 or something. It should be about an inch wide. That's my apologies. 0.92 inches wide by about 2 inches long. And those should be your overall dimensions. The dimensions of the fillets don't really matter. Just that the radius of all of these in here is 0.065 inches, or 65 thousandths of an inch. And then this hole is 0.201 inches. Alright, so when we're first getting set up, we're going to import a file into Fusion. If you already have it designed in Fusion, it doesn't really matter because you just already have your design open. And we're going to make sure that you've imported your file, you've uploaded it. There's a nice little upload tab here. You can import step files from SolidWorks and other CAD softwares if you need to. But for our purposes, we already have mine uploaded here. So once you open it, you're going to go over to this manufacturer tab. So on the top left right now it says design. We're going to go down to this manufacturer drop down right here. We'll click on that, and that'll allow us to program the machine to kind of tell it how we want to make our tool paths and generally make our part. Also, don't forget to save as you go so you don't lose progress. But yeah. So if you're in the Fizz Fusion teams, I'm in my own folder under my name. You should be in a folder under your name if you've been added to this. You should have access to our cloud library. The way you want to make sure that's enabled, you go to your profile on the top right, go to Preferences, go to the drop down for General, and click on Manufacturer. And then make sure you have Enable Cloud Libraries checkmarked. This allows us to give you basically proven settings that we've already ran on our machine for feeds and speeds, which you'll soon learn about. Yeah, so now we've got our file, we've got it in the correct area, we have everything set up. We just need to start making stuff happen. So the first thing we're going to do, we're going to go make a new setup. So up here you have, I'll give you a quick little rundown of this toolbar here. We have, so on the left we have our setup tab. This is where you'll make your setups. You can also make stuff with posting programs in here. And then we have our 2D operations here. So this is where your milling machine is going to follow like a a 2D path. It's not going to follow complex 3D geometries. And then, believe it or not, in the 3D panel, we have toolpaths that are more able to follow 3D geometries. These are going to be primarily using like ball end mills, because those allow you to get more of a, like, you can kind of use it as like a tangential edge to the part and get a really good approximation for these complex curves. Then we have drilling right here. This is how you drill stuff, and we don't care about this. This is multi-axis stuff that we don't have available for you guys. And then you can also manage the tool library and stuff in here, but we shouldn't need to change anything in that for our time right now. And then the other thing right here, oop, didn't mean to click on that. This right thing right here is called the setup sheet. We are going to be using this and have people submit digital PDF copies of their setup sheet, just so we know what they're doing and have a little bit of documentation on usage of our machine. So first things first, we're going to click on the setup here, and it's going to basically pop out here. It's going to give us this a bunch of like stock stuff. By default, it's going to probably be a relative size box. We want to make sure we select a fixed size box in this little stock tab. So I'm going to go over to the stock tab, second one here on this banner, fixed sized box. And I'm going to make my width 2.5 inches. So this width, I'm telling it, this is all like the stock size, so the part, the dimensions of the piece of metal we are going to bring down to the size of our final part using the machine. And then for my depth in Y, we're going to do 1.5 inches. And we're going to do 0.52 inches in our Z. Alright. Now, you kind of see this is not really lined up with our part. We will worry about that in a second, but that's because right now it's thinking that we have our axes are a little different from what they are going to be in the machine. We're going to have the x-axis, as you can see right here. That's going to actually be along like the long side of the domino, and we'll get to that in a sec. So the other thing we're going to do here, while we're over here, we're going to change our model position here to an offset from the top, and we're going to do 0.03 inches of offset from the top. Now I'm going to go back to this left one right here. This is our setup. This is where we're going to basically tell the machine where we're working. So this little stock tab in the setup, that was telling it like dimensions of the stock, how our part is positioned relative to it. Now we're going to tell the machine how we're orientating our part in the machine. So you want to first here, you're going to click on the machine type, select, and then in the cloud library, you should be able to select the tormach 1100M. And then just select, voila. The operation type should be milling, and we're going to tweak some of these things in here. So our orientation, we want to select X and Y axes, and this is going to fix this stock size not matching the domino. And we're just going to select some edges that are parallel to where we want the axes to be. So I'm going to select this edge right here for my X, and for my Y, I'm going to select one of these edges that's running this way. Now you'll notice the Z is now on the bottom of the part. I really don't want that because Z is going to be kind of like looking up. So right now that would be like if I'd flipped the domino upside down, which is going to be for our second operation. So we'll do 2 setups. This first operation is going to be like one orientation of the domino clamped, and then we'll do all the stuff on that, and then we'll flip it over. So to fix this Z being flipped, I'm actually going to I'm going to flip this little check mark here for flip Y axis. And voila, it's now moved that Y axis all the way over there, and now my coordinate, like my directions are good, but I don't have my origin or my zeros in the right place. So I want to put it somewhere that's going to be easy to find on my stock, so I can use my probe on the tormach to find the center or some other defining feature that I want to use. So there's an option to select a box point on your stock. We're going to be using this for our first operation because we can. There's an option to find the center of a face in the using the tormach. So we're going to be using that, and so yeah, you'll select this box point, you'll click this little middle dot on the top. Now you can see we got our stock kind of where we want it. We got our part in there. It's all looking pretty good, and that's all we need to worry about for this. There are some other options in here, but you don't need to worry about them. Like there's options to import vices and whatnot, but we're not going to dive into that right now. If you're curious in that kind of thing, reach out to me and we can talk about it more, but that's beyond the scope of what we're doing right now. So we're going to do OK here. That's going to let us get our part kind of oriented on this machine here. So we can actually hide this machine if this is getting in the way, but you can kind of see how if you did import a vice geometry into here, it would be very useful to see if it's going to fit in the machine, how you're going to mount stuff. And in industry, a lot of people will set up fancy setups for one-off parts, but for this project, all we need is a normal vise, so we don't need to worry about mocking up anything. So I'm actually going to hide the tormach, so I'm going to toggle the visibility on it. That way it's a little less distracting. Alright, so we have our setup. So we've kind of told the machine where our part is. We told it the size of the stock. So the machine, or rather the program that will tell the machine what to do, knows most of the information about what we have, and now we need to tell it what we want it to do. So the very first thing we're going to do is kind of rough off a bunch of stock, right? So there's a lot of like excess material just sitting there. So if I click on these, you kind of see all this yellow stuff is like basically aluminum that we have to remove from the part. And so the general process when you're doing these toolpaths, you're going to kind of start with like a roughing thing that removes a lot of material really fast, doesn't have a great surface finish left over. Then you're going to move to like some more like finishing passes where you're going to be working on like getting like a nice clean finish on all these like flat surfaces. You're coming in with your ball and mills and getting all these round surfaces. You're drilling, and then finally you're going to come in and you're going to take your engrave tools, your chamfers, and you're going to kind of clean up your part. And then that's kind of the general process that people take. And so yeah. Okay. Let's get that mic fixed. Alright, so we've gotten to this point. Now I already went over that. We're going to kind of follow that rough process of going from more roughing to more finalized stuff in our operations or in each setup. I'm actually going to right click on the setup, and I'm going to, or actually not right, I'm going to left click on it. I'm just going to change it to op1. It's a little bit easier to memorize then. And so the very first thing I'm going to do a little adaptive clearing. So I'm going to click on this right here. It's this 3D thing. And this is going to be one of those more roughing toolpaths. So I'm going to tell it the tool that I want. So we're going to select a tool. Assuming that your cloud library is working, you should be able to navigate to the Mach Speed Finger Flinger. That is the name of it. It's a little goofy, but it was created by a lot of students in the past. So we're going to select tool, where is it? 45. So this is our 1/2 inch aluminum end mill. We have a little bit of information here. So you can see we have a product link here. We have some stuff about the geometry, kind of some stuff about the settings here. But this is all you really need to know. It's a 1/2 inch tool 45, and we'll get into some of the more like niche stuff later, or just more deeper stuff. So I'll do select. And you can kind of see we have a couple presets here. So we're going to be using the high material removal, and then these other two settings are good for when we're going to be doing our finishing passes later. So we'll just leave this selected, and I'll very briefly go over the use of FS Wizard. So FS Wizard, I'm going to quickly open that up here. fswizard.com, very useful thing. I'm just going to go to this browser app. It's free to use, and this is a great way if you are unsure about the settings that you're supposed to be running for a particular tool, maybe it's not something we have proved out in our tool library yet, you're going to come over to this FS Wizard website. There's also an app on your phone, which is really useful if you're like on the machine, kind of trying to look at stuff. And we're going to have a bunch of options in here. So this is basically going to tell the machine the RPM of this. Like, it's like a calculator to find ideal RPMs for your spindle, for your like end mill, along with how fast you're moving it, how deep in the material you're cutting, and it takes in a lot of parameters. So there's a bunch of different tool types in here. The ones we're going to be using today are solid end mills and solid ball end mills. I'm only going to come into here once because we already have proved out settings for all of our tools. So it's just a little overview to show you guys what's going on. So I'm going to have a solid end mill selected. Generally, we're going to be using carbide tooling. There are occasionally going to be other things, but carbide is the most common. And this particular end mill has no coating on it. And if you're ever curious about like anything on here, just check the manufacturing website, like whoever you bought the tool from. They usually have useful data sheets and stuff that you can reference. In fact, they might even have recommended settings that you can try out before you even run it through this, and those can be really useful. So if I know the diameter of my end mill is going to be 1/2 inch. It's going to have 3 flutes, so each flute is like one of those ridges coming down on it. So I'll actually briefly go over here. If you do edit here, you can add settings for a tool. So this will kind of very briefly go over like the tool geometry here. So your number of flutes is going to be each one of these little ridges. Each one of those is a flute. General rule of thumb, 2 to 3 flutes is about what you see for aluminum. And then more than 3 flutes, so like 4 or more, is typically reserved for harder materials like titanium and steel. So yeah, there's a lot of information about our geometry in the program here. You just got to make sure this matches the tool that you're actually going to be using on the machine. So there's a lot of stuff in here that you can use that'll help reference stuff, but we only care about this length below holder, the shoulder length, and the flute length. So this is all about 1 inch, and this is about 1.5 inches. So this is basically going to be what we use to tell the program, our calculator, like our tool stick out is going to be about that 1.5 inches. Flute length was about 1 inch. There was no corner radius, so corner radius would be like a little rounding on the cutting tip of the end mill. And all these other things I think match roughly what that had. So I'm actually just going to leave those as they are. And I'm just going to go down to here now. And we're going to be looking at this. Around 36% width of cut. That's a good benchmark. You can always, you're going to kind of, there's a couple formulas out there for calculating this kind of thing. So we've told it what end mill we're using. We're going to be going up here to select the material now. So this is 6061 T6 series aluminum. That's the material we're going to be milling our dominoes out of. But there's a host of other materials here. So these will help give you an idea for what you want to be starting out with for settings. So I'm going to be looking here at the depth of cut, the width of cut. So this is kind of, your depth of cut is how deep with every successive pass that your tool is going to be cutting, and your width of cut is like how far over its own like previous path it's going to be cutting. And that'll become very apparent when we go over to the programming and we like start doing those tool paths in Fusion. But for right now, I'm just going to drop this down to like 1/2 inch, just because I don't want it to be quite as aggressive. And yeah, we're going to start out with that. I'm just showing you this, by the way. You don't have to be using this. So we're going to be also changing our RPM because our machine maxes out at 7,500 RPM or 7,500. And this looks pretty reasonable. We have the width of our chips, or our chip load, is going to be about 3.5 thousandths of an inch. And yeah, okay, this all looks pretty decent. So these would be some okay settings to plug in for our machine. We might actually have to slightly lower our depth of cut more with this, because you can see there's this little power requirement here, and I think our machine might be on the edge of its power requirements if we were to run with these settings. So you always want to double check these things, and if you're ever having questions, just come ask us. We will be more than happy to help. It's always preferable that you ask us a question before you break something, and we will never judge you for not having the necessary knowledge. It's always a learning process. We're at a university. We're here to help you learn. So we can take this information and we can tweak that either by editing, cutting data where I was earlier, or by going through this menu here. But yeah, so that's how, if you had a new tool, you would go and change those settings. You can kind of see these are very similar settings to what they had. So 7,500 RPM, about 90 inches per minute. That's about what it says up here. It was like 80 inches per minute, 7,500 RPM. And this just has slightly different depths of cuts and widths of cut, but roughly the same. So that's a brief overview of FS Wizard. Super useful tool. Now we're going to be setting up our tool paths. So I've told the machine kind of the formula it's going to use for like how fast I should run the tool. Now I need to tell it where I want it to cut. So I'm going to go over to this geometry option here, and we're going to just select model here. And this is basically just going to tell it, okay, we want you to machine all of the model service or the model options here. So we're going to tell it okay at first, and this is just going to show you guys what's going to look like. This is going to, by default, the 3D adaptive will leave behind like some excess stock for finishing later. You can change that if you need to, but the general idea is that we want to have extra stock. So this looks pretty good. It looks like it's going all the way around the model. It's going to be cutting as deep as we want it to, except it maybe is leaving a little too much stock at the bottom here. So I'm actually going to ask it to go a little bit deeper. So we're going to go back to edit this. So I'm going to right click on it, do edit, and we're going to go to heights here. And I'm gonna get rid of this offset here on model bottom, or say 0 inches, and that should tell it to kind of leave the it's gonna come all the way. Yep, you can kind of see how before we didn't have, it kind of only went down to here, but now it's going all the way past that chamfer and it's going all the way down to this bottom part. And that's just going to help our tool have more even engagement when we're coming back around to clean up everything. Alright, so this looks very good. So all these blue lines, these are kind of like where the tool is moving while it's cutting. Yellow lines are where it's moving fast, or using like a rapid, as we will call it. And then green is going to be kind of a lead-in or a transition where it's not cutting, but it's still moving at the same speed as if it were cutting. And you can also see all this by if I were to right click on our program, we can do simulate, and this will simulate how we're cutting our part. So there's a nice little speed slider down here, and I'm just going to select start simulation, and you can see this is roughly what it's going to look like in the machine. And this simulation tool is incredibly useful and important, especially if you are new to this, but even more so when you're dealing with more complicated stuff. You always want to be double checking your programs to make sure they look good using a simulator first. Everybody in the industry will always check their programs with a simulator just to make sure they're not going to crash the machine, that their part's going to turn out well, there's no errors in the code. So you can kind of see how all of this is going together. So it's going to kind of take off all these sides, and it's going to come up and take off a little bit of this top material, and it's looking pretty good. So I can always turn up the speed now that I know that it's looking pretty decent. Voila. Looks great. That's exactly what I wanted. So now I'm going to exit simulation because I've checked the simulation and it looks good. And I feel pretty good about this toolpath. There's a couple other settings in here we can tweak if we needed. So if I needed to avoid something, or if I felt like I needed to change some stuff, like if I wanted more or less stock left over, I can uncheck it right here or change the values. And then over here in linking, there's a couple other settings in here you can play with if it's not working properly for your stuff, but you can always just come ask us and we'll help you. We have a lot more experience likely than you do, so we're just gonna be here to help you. So yeah, after I've got all that set up, I'm just gonna say okay, you know, we got that saved, and it's moving on to the next step, which is going to be facing it. Okay, so facing, it's one of these 2D operations here. This nice little drop down. There's a really nice intuitive way to see what something is going to do in Fusion, and I'll kind of show you what it'll look like if you just kind of hover over stuff. So we're going to go to face here, and I'm just going to select this top face. I'm just going to click on this. We're going to use that same tool as previously. It should still be selected. We're gonna try to use the same tool for as long as we can before we switch it to something else, just because it makes things a little bit faster on the machine. You'll understand a little bit more once you're actually running the machine, but generally the less you have to change the tool, the faster and easier your program is going to be. So we're going to see that we have this selected for our geometry, and I'm just going to go to heights real quick. Looks good. Everything looks decent. And we're going to do okay. Just kind of take a look at that. We're going to see it's going to generate it, and it looks pretty good. But there's a couple things that I forgot to do that are kind of becoming apparent. So you see, we're taking a lot of these really close passes, so it's not really being very efficient because we're only removing a little bit of material, and it also left this little seam behind here, which that could get in the way right here. You can kind of see that. That could get in the way of some stuff later. So what we're going to do, we're going to go back to edit this. Oh, not edit tool. Misclick. So we're going to edit it, and we're going to go to passes. Actually, first, we're going to change our preset. So under tool, go to preset, and we'll go to the facing preset. And then we're going to go to passes, and there's a nice little option for stock offset. You can hover over it. Basically, this is just telling it, hey, I want you to go past where I told you I wanted you to machine, just to like get rid of anything that could be in the way. So this is helpful if you have a really rough stock and you don't know exactly what it is. If you're, in our case, our flange isn't quite getting machined. So I'm just going to add 0.2 inches. And I'm going to say OK. And you should see it's a very different output this time. Yeah, so there's no flange here, which is what I want to see. And there's a lot less passes because it's only coming in and finishing that top surface, giving that nice, smooth, good surface finish there. Alright, so now that we have our facing operation, we're going to go do another 2D operation using the 2D contour. This is going to be kind of like facing, but for the sides. It's going to leave that nice, smooth, good surface finish. So we're going to change it to finishing. That's going to be the preset of choice for this. And then for geometry, we're going to select this edge here. Now, basically what this is telling the machine to do is it's going to trace along that edge with a tool to kind of cut out that profile. So it's going to kind of fall along this. The problem with what I've done right now is the bottom of the tool only goes to the contour you select. So if I say OK, it's only going to cut down to here, but I want to go just a little bit further. So I'm going to go to this heights tab here, and I'm going to change my bottom height from selected contours to selection. And I'm just going to click on the bottom of my domino here. And now, if I push OK, it should, yep, just wrap around, do one quick little finishing pass all the way around it. And if I were to simulate it, it would look just as I described it to you. And yeah. So that's the contour. So we've kind of roughed out the shape of our domino at this point. We have all of the overall dimensions, and now we just need to do a little bit of cleanup. We need to put in the finer details of these holes and everything. And we need to do drills and break these edges, put bevels on them using our chamfer tool, and then we'll have to flip it over. So the next part that we're going to be working on is doing all of these nice domino features. So the little holes and all that, little slot here and everything. So we're going to go to 3D, and we're going to use the scallop operation right here. And as you can see, this tool is way too big to fit into here. So we're going to use a tool more appropriate for the job, and we're also going to use a ball end mill, because a ball end mill will allow us to get this more perfect for this geometry. So we're going to go select a new tool. In the cloud library, that's going to be, I believe, tool 6, which is the 1/8 inch ball end mill. Should just be a nice little 2 flute. I'm going to select it. We're going to let it sit on the default preset, and we're going to select geometry. So the way I like to do this is I'll give it a boundary, because I don't want to select all of these little faces in here to machine. That's kind of slow. So I'm going to actually have a selection here under this machining boundary, and I can literally just like click on the edges of all this stuff. So I can click here and here and here and here, and I'm just going to do this to all of them. And this is basically going to tell the machine, I want you to machine everything that's in this chain, like kind of in this like area bounded by that. And so yeah, for me it's just these 8 different regions. If you did a slightly different number or set it up kind of weird, it'll be different for you, but this is how it should look for me. Now if I push OK, it should work, but there might be a small thing where it'll kind of gouge the surface. So we'll let it generate, and I'm just going to double check by hiding the model to kind of see what this end result is actually looking like. And you can kind of see it's a little pixelated. That's just how the simulation works, but otherwise this looks perfect for me. This looks exactly how I wanted. It's kind of doing those holes, it's spiraling into them kind of, and that's just what I wanted to see. So I'm going to unhide the model and move on to the next step. So now I've got most of it done. Let's drill a hole now. So we're going to click on the drill option, and we're going to select, I believe it is drill 170. So that's going to be the 0.201 inch 135 degree drill. It's a number 7 drill. And I'll just select that. Leave it on the aluminum preset. And then for my geometry, I'm just going to select this hole. And we're going to have to select a little option. I'll show you what the difference looks like. But if I just let this be how it is right now, it's not going to actually drill all the way through. It's going to drill until the point reaches the bottom of that hole that I selected. So if I want it to actually go all the way through, so I can actually have a place to mount it on my keychain, I'm going to have to go back to edit this, and we're going to have to go to heights here, and we're going to have to do drill tip through bottom. And I'm going to also select the bottom of my hole because I catted a little chamfer in here. So I'm actually going to do selection and this bottom surface. And you kind of see how it's going to drill all the way through now. And I'm actually going to tell it to break through just a little bit more. We're going to do 0.05 inches. And that's going to just tell it to drill all the way through, just to make sure we're like very clear and we're going to have a nice clean surface there. And there's also, for drilling in particular, there's different cycles you can use. So if you've taken the metal shop training, you should know about the peck drilling that we'll try to have you do, where you kind of You push it in a little bit and then you pull it out quickly to allow the chips to get out. With a soft material like aluminum and how little we're drilling, we probably don't need that, but I'm going to just show you how to do it. So the default way is going to be, you're going to have this drilling wrap it out, where it's going to, you can kind of see in this preview on the top left, it's just going to go all the way in and then come all the way out. But what we want to do, we want to have it do chip breaking or deep drilling, and what that allows you to do is kind of pause and allow those chips to get out so they don't gunk up your drill bit and kind of clog it up. So we're going to do chip breaking partial retract, and we're going to have a pecking depth of, let's say, 0.1 inches. That's going to be kind of how far it goes at a time. And we'll just tell it okay. And what this should look like from the machining side of things. So if I go to simulate it, it'll go in and it'll kind of stop. Oh, that's way too fast. Slow it down. Hold up. Okay, I think it's just moving a little fast, but it's stopping very slightly just to allow the chip to break. Yeah, you see how it's like kind of jumping a little bit? That's all it's doing. It's very subtle, but that does make a really big difference. And sometimes you miss those things if you're going too fast, so it pays to be a little careful if you're simulating yourself, just to check around things that are a little bit more sensitive. So I'm going to exit that simulation. Looks good. Now the last thing we got to do on this side is add that little chamfer, add that little bevel on the outside. So we're going to do a 2D chamfer, and we're going to select the, it's going to be tool 14 under the Mach Speed finger flinger, which is going to be the 1/4 inch 45-degree Haas chamfer and mill. And just select it. We're going to just leave it on the default preset, and we're going to, let me double check it. Yeah, this looks perfect. Yep. So we're going to select the contours that I want to chamfer. So at the very minimum, you should be chamfering these like outer edges, but I also added a chamfer to this, to the top of all these, so I want to do that as well. So I'm going to select this, kind of the bottom edge of these chamfers. There's a couple different ways you can do chamfers, and you can play around the settings if you want, but this is the way I like to do it, because I basically CAD all my chamfers into my parts, because that's how I do it. Some people don't CAD their chamfers in, so what they need to do is actually make the chamfer based off of like a sharp edge that's in the CAD model. So for me, I need to slightly tweak some of these. So if I go to passes here, there's this thing called chamfer tip clearance, or chamfer clearance, I mean, and I'm just going to set that to 0. And what this should do is, if I tell it OK, it'll basically go right up to this edge here. So yeah, perfect. You see it's just going like up to this edge, and it's not going to try to like cut something new. It's just going to follow that contour exactly, which is what I wanted it to do. And as you get more familiar with this, you'll realize that you just have to check the output result and see that it's going to look good. Sometimes these strategies aren't always the best way. There's a million ways to machine a different part, so you just got to pick one of the better ways, basically. Okay, so this is basically the entirety of our first operation, or our first setup that we need to take care of. So now we're going to flip over the domino. I'm going to flip it over like this way in the machine, but it's also fine and acceptable to flip it over like this instead. So it's kind of like hot dog or hamburger folding, if you remember that from like elementary school. So the way I'm going to do that, I'm going to make a new setup, and I'm going to leave most of these things the same. It's going to be the same machine, and I'm going to quickly go over to stock real quick, and we're going to make sure we're in from preceding setup. And if we check this continue rest machining, this is going to basically tell the stock, or tell the programmer, like our Fusion basically, that we've already removed a bunch of material, so you don't have to go and cut that away again. Because what this will do, you can kind of see, I'll just spawn it in basically real quick. I'm going to hide the machine so you can see it very clearly. But all of this like dark stuff is the material that's still there, and the light stuff is the stock that we already removed. So I'm going to go back to edit this, because we need to actually do this little flip, right? So we were oriented like this, and I want to flip it over this way. So we're going to change our orientation. We're going to select our X and Y axes, just same as the other one. I'm going to flip my Y axis again, because I want my Z going up this way this time. And we're going to change our box point. So on the other side, we used the stock box point, so that was kind of something based off the material, because we hadn't machined anything yet. But now we're trying to make this line up with what we already have on the machine. So it's all of a sudden really difficult to line it up if we were to use the stock to find stuff. So what we're going to do, we're going to try to find already machined features that are going to be much more accurate to like touch off of using the probe to find a new offset. So the easiest way to do this, we're going to go to this model box point option under origin, and we're going to select this front left corner here. So this one right here. And that'll move our origin there, because with this we can touch off of this face right here and this face right here. Let me a few things. Turn on do not disturb now. So we got our origin set up here in this bottom left corner, and so that's so we can find these machined edges here with much more precision than if we tried to touch off of the stock again, because we're going to be holding it in the vise, now clamping the actual part. So this is all I need to do for the setup. A lot of stuff carries over from before, and you can kind of see this is what it looks like now, and we're going to remove all this material now. So next up, it's going to be very similar. I'm going to basically do the exact same stuff. I'm going to use the 1/2-inch flat end mill that I already had from before with this high material removal, and we're going to tell it to machine the stuff again. So we're going to do model, and I'm just going to select OK, and it might, okay, so here's one of these times where you just got to be double checking your program, because if I ran this right now, because I'm using the vise to clamp the edges of this domino, I would absolutely nuke the end mill. It would just shatter into a million pieces or gouge a ton of the vise clamping it before I stop it. So we want to go and change those heights again, just to make sure we're not hitting stuff we don't want to hit. So we're going to go back to heights, and I'm going to do a selection with 0 offset on this chamfer right here. That way I know for sure it's not going to like go deeper than that. Perfect. That's what I wanted to see, and that's what I'll get. So now we're gonna run back the same facing operation. Basically, we're gonna do that again. So just face, using that same tool, using the facing preset. We're just gonna select our geometry, and then we're gonna make sure we have our stock offset still just like before. I'm just gonna say OK. Should be happy. Same old as the other one, so perfect. So now we've kind of machined this top face, we've machined the edges, we've machined everything on the bottom here. Now all we need to do is chamfer this hole right here, the edge of this, and do our engrave. So I'm going to first do my chamfer. So go back to that 2D chamfer. We're going to select the tool we used before, the tool 14, 45 degree chamfer. And we're just going to select these contours here. Make sure we're going back to this passes option, getting rid of that chamfer clearance. And I'm just going to tell it OK. And that should be all I need. Very similar settings to before. Virtually identical. Looks great. In fact, they're so identical that I could have, if I wanted to, I could delete this and literally just right click on the chamfer from the last operation. And I can copy it. Right click on this, which actually I'm going to name this to op2 while I'm over here. So I'm going to right click on this and I'm going to paste it. And it'll save basically all of the settings here. So if I go to edit it, all I need to do is clear this geometry and select the other ones. And it should have all the settings I put in there from before. And that's a great way to save time. You can also copy setups between parts. So Crimson Robotics does that for a lot of their parts because they water jet parts and they have to drill a bunch of holes in them. So they keep the same setup and then they just can copy it between all of their parts. Now the last thing we're going to do is our engrave. Now what you need to do for this, you just got to have these profiles in your part, right? This is much more of a art right here than it is of a science, because you're kind of just finding the best looking thing. Because at least for this particular engrave, there's not really a spec or anything we have to hit. We're just adding your own like customization to this part. So I'm gonna select the 30-degree engraving bit, tool 50. Select it, and I'm going to make sure I'm on the aluminum preset. And for my geometry, I'm just going to select the bottoms. Oh, this is circular. Sorry, I thought I did engrave. I clicked on the wrong thing. That's my bad. Okay, so tool 50, which is our 1/8 inch 30-degree in chamfer. Make sure we're on the aluminum setting, and we're going to select the insides of all of these. Now you notice I'm not selecting this bottom right one. That's because the way I imported this geometry, there's like a little weird breakup here where it won't actually let me, so I have to leave that one behind. And if I just select OK, it's gonna look funky. Alright, it's gonna be really deep probably. So I'm actually, this is where I'm gonna really want to hide my model. You can see that's like, it actually does look pretty good with this particular logo, but what I'm trying to do, I want to kind of trace it. I don't want to like overwhelm the end mill. I don't want to like break it or anything. So I'm gonna go back to right click this, we're gonna edit it, and we're gonna play with the height. So I'm gonna make my model visible, and we're going to do a top height from selection. It's going to be, I'm going to do the top of this. And what that's telling me is I'm going to change this bottom height to only go basically as deep as I want it to relative to the top of the surface. So this is going to be much more akin to like tracing lines. So I'm going to do 0.01, which is 10,000ths of an inch. And it should basically just trace what I wanted it to. So if I hide, nope, not my setups. If I hide my models, yeah, that's exactly what I wanted. I wanted to have that kind of like tracing of it rather than like going all the way deep. But either way does work as long as you're not running it too hard. And you'll know if you're running something too hard because it'll either break or it'll sound very angry in the machine. If you are, as always, if you have any questions, just ask us. We'd much rather you have the foresight to ask us one short little question than break something. And yeah, that's about all there is to actually setting up the tool paths. So we've completely programmed all of that. Now I'm going to briefly go over a couple other things before we end this video. So we're going to go to do an NC program. So you can go to here. This is basically what you do when you're gonna load your files onto a flash drive to actually kind of load them onto the machine. So we're gonna make sure we're using the tormach path pilot here, and we're gonna give it a name, a descriptive one. I'm gonna do Kerrigan Domino because that's my last name. And I'm gonna select an output folder. We're gonna do downloads for now. You can also post it to your Fusion Hub, so if it's like a cloud thing, but we don't need to worry about that. And we're gonna give it a Kerrigan Domino op1 is what I'm gonna do, because I want to be able to differentiate between this and the second side, because we're gonna have to post them as two different files for each setup because we did that flip over. So I have my domino op1. It's gonna just be op1 in my NC program. That's gonna be, you'll be able to see that in a moment what that looks like. There's a whole bunch of options in here. You should not have to change any of these. But over here in the operations tab, this is stuff you do have to select. So this is basically me telling you like which tool paths you want to take for your file. So since I have everything in one operation, I'm just gonna click on the entire folder for that operation, and if I push post, it'll post that file out. But if I maybe have half of this and then I realized, oh crap, I forgot to do the other half, I can just check mark these individually, or if like maybe I made some changes and I had to run a particular program just to fix something, I can always come in here and do that. Maybe my program's really long and I want to break it up into several smaller programs. There's a great way to just come in here and check only the ones you want to do at a time. So for now though, I'm just going to check everything for op1, and I'm just going to do post. And it posted the file, and then I'll do the same thing. Just be Kerrigan Domino op2, and I'll name the NC program op2. Let it stay in the same folder, and then I'm just going to select op2 here. So second operation, and I'll do post again. Now if I go to my file explorer, it popped up my other monitor. I'll drag it over here in a second. You can see, hold up. Alright, so you can see how we have domino op1 and domino op2, and then I can just drag and drop those onto a flash drive if I want, and I'll put them onto the machine from there. Now the other thing that you got to do, oh, we got a little error popping up here for no reason at all. Sometimes stuff will get angry at you. If there's an error, it's usually pretty descriptive, but if it's something you're worried about, just ask us and we'll take a look at it. Make sure it's not something that's going to like destroy our machine. The other thing we're going to quickly go over is how to do a setup sheet. So setup sheets are, I'm just going to leave it in downloads. We're just going to say NC programs. Cool. New folder, do NC. I'm just doing NC. Okay, so this is going to kind of give you a brief little overview of everything about your operation. So it'll have a little picture of your setup. If you had devices or the machine in here, it would include that. But it's going to give you all this more important information. It's going to tell you your stock size, your part dimensions. It's going to tell you kind of the dimensions relative to your work offsets. And then it's going to tell you how many operations you're having, your maximum and your minimum Z values. It's going to tell you your maximum feed rate, your maximum spindle speed. These are all really important information just to have on you with the machine. So like if you're running the part, you can always just quickly reference a setup sheet. So it'll tell you all the tools. It should tell you how to set them up so you're not going to run out of clearance or run into maybe issues with chatter because of vibrations. And we just want to make sure you have digital copies of these downloaded, and you'll submit them to us before you use the machine when you're doing your own parts and stuff on here. And it's also just an important tool for you to be able to use. So yeah, you can see it looks like it included the second operation in here. So it's actually including both of them. So I think there might be a setting we can tweak for that, but you just have to pay attention and know all that. So I think if I were to go in here, I can also set if she's fully customizable. Select folder. Oh, okay. So what's going on is the NC programs here on the right, they're having some conflicting things. So if I were to delete this one, it should only have the one operation now. And yeah, so you can take this setup sheet, you can reference it for everything. Looks like it's still being a little finicky. I haven't played around with this a whole lot, but the important stuff is there is a lot of really useful information in here that you're going to want to be able to use. So just have this with you, and you can just reference it. Maybe have it on like your phone or something when you're running the machine. Then there's also, it might be getting slightly mad because, okay, so, nope, that looks fine. So, really quick, I'm going to go over something. This WCS is the work offset. So by default, most machines use G54 as the like base offset that you use, and this is like where you can store several different offsets, which are like your zeros on the machine. So G54 is generally the most common one, and you shouldn't change this from G54 because you'll likely crash the machine. But just know that that is a thing, because I think the setup sheet was getting a little mad at us for having, it might be because there's several setups going on with different orientations, but they label the same work offset, which isn't a problem for us, but this is just a little finicky. And yeah, that just about concludes how to do the cam for our domino. I'll quickly check we haven't missed anything, but yeah, that's just about everything. We're gonna have, if you missed it, there's going to be another video that went over the CAD of this domino, and there's also another video that's going to go over general best practice for CNC machining that I'll put out there, and there's some other good resources I'll link. But that's all we need to do here. So thanks for watching, and I really hope this was helpful.